Hi everyone, I'm Cynthia Parks, Senior Instructor in the Plant Food Environmental Sciences Department here at the Dalhousie Faculty of Agriculture in beautiful Truro, Nova Scotia. Today we're going to be demonstrating 4 experiments from the Digging Deeper procedures: soil salinity and pH, respiration rate, soil moisture, soil texture. We're going to start today with the respiration rate. In our first experiment, respiration rate, we're going to start by taking 50 mils of our field moist soil and placing it into the Pasco carbon dioxide chamber. I have the soil in this container, in this weigh boat, so that I can gently scoop it in to the bottle. The bottle has a narrow neck, so we'll try not to make too much of a mess. Remember, this soil is field moist, so these samples were taken and have not been dried. If your soil has dried out, you can use a mist bottle and spray it slightly to re-moisten it. So I'm going to start with my probe and turn the little button on here at the end. You can see the red lights flashing, indicating that it's on. It's time to launch the app for the Pasco probes. We've turned on the probe by pressing and holding that button until we saw it light up red. Then we're going to turn on the Bluetooth within the app. You're going to select the wireless CO2 function, which corresponds to the number on your probe. You're going to then select Table and Graph, and you will see the screen show up. You're going to place the probe in the chamber and make sure there's that good seal. When that's complete, you're going to hit Start. We also want to make sure that it's away from everyone's breath, which could affect our data. We're going to start the data collection in SparkView. After approximately 1 minute, to avoid any initial instability in the readings, we're going to record the initial CO2 concentration. The data will collect for 3 minutes. So you're going to stop the timer slightly after 3 minutes, and then you can scroll back to see your data reading at the 60-second mark and at the 180-second mark. The class should note the temperature at the time of the test using the temperature probe. You'll turn it on by pressing and holding the button. You're then going to connect the probe to the Bluetooth. You will see it in the right-hand part of the screen. Remember to match up the temperature probe with the number on the screen so you'll know you have the correct probe working. If you haven't shut off the carbon dioxide probe, it will still be on the screen, so be sure to do that. The data will remain on the screen because this is the same experiment. So we just have to push the plus button and we'll have a new screen within the same experiment. Once you place the probe in the wet field soil sample, you'll see the temperature start to change on the app screen. Give it a few seconds to stabilize, and then you can record that temperature. And now we'll have our complete data. So we have our initial CO2 in parts per million after 1 minute, the final CO2 after the 3 minutes in parts per million. We're going to have the difference in the carbon dioxide in parts per million, the elapsed time in seconds, and the rate, which is the difference in the carbon dioxide divided by time, which will give us our parts per million per second. And now we have our additional temperature. For our next experiment, soil salinity and pH, we're going to start with 50 mils of our field moist soil, and we're going to place it into a tall beaker or graduated cylinder with 250 mils of water. We're going to be using the mason jar so we can shake it up easily. So we're adding our 50 mils of the field moist soil into the mason jar. We're going to add our 250 mils of water, and this is distilled water for the experiment. Always important to label your sample. And we're going to mix thoroughly and then allow it to settle. The settling process will need to take place overnight. We're going to launch the Spark View and connect to the Pasco conductivity probe. We're going to carefully insert the probe into that overlying water from our sample, which has set overnight. We want the probe to be about 2 centimeters deep, being sure not to go anywhere near the material of soil on the bottom. We don't want to disturb it. Salinity, conductivity, is measured in microsiemens per centimeter with the Pasco probe. Once our measurement's taken, we have another option. We could also use the pH papers for our pH, or you can make the purple cabbage juice within your class. All of these procedures will get your estimate of pH. Our next experiment is soil moisture. You need to dry the soil, and access to an oven set at the lowest setting, or 40 degrees Celsius, can be very helpful. If you don't have an oven, you can dry the soil laid out flat on some newspaper in a warm location for several days. When we have our dried soil, you're going to be separating that sample in half, and we're going to weigh the tinfoil pan first, and we're going to note the weight of that tinfoil pan using our balance, and then we're going to weigh our soil. So with our balance, we want to make sure that we have it tared to 0, and then we're going to weigh our tinfoil pan, and this one weighs 4.1 grams, for example. So then we're going to add our divided soil sample to the pan and note the weight. The pan and the soil together weighs 118.9 grams. Be sure to label your sample, place in the oven overnight to dry. So this is our field moist sample. We've done our wet weight. Then it can be dried in the oven or on the newspaper. The next day, when you come to weigh your dry sample, you already know the weight of the tinfoil pan. So you have your balance tared to 0, and you're going to put your dry soil on to get your measurement. And the dry soil now weighs 106.8 grams. You're going to observe the calculation. Moisture percent equals the mass of the wet soil minus the mass of the dry soil divided by the mass of the dry soil times 100. And this will give you the percent moisture in your soil. Our next experiment is soil texture. We're going to experiment with separating the soil into its component parts of sand, silt, and clay by percent. We're going to take 125 mils of our dry soil sample and add 250 mils of our distilled water plus a teaspoon of dish soap. And this will allow all those soil particles to mix together well for us. So we have our 125 mils of the dry soil. We'll put it into our mason jar. Then our 250 mils of the distilled water. We'll add our teaspoon of the dish soap. We're going to cover it and shake it up really well. Mason jar is really good to use for this because it won't leak. You're then going to put that bottle down and not touch it for at least 24 hours, but we need to watch for 1 minute. The sand will settle. After 2 hours, the silt, and then we'll wait for the rest of the clay to settle out. We've had our timer running, so at the 1 minute mark, we'll measure our sand. This sample is lots of sand. It's measured 2.5 centimeters. The learners will be timing and marking this layer with a marker. Then we have our silt layer, which forms after 1 hour. The silt measurement will be from the sand layer up, and this measures 0.8 centimeters. When our sample has set for 24 hours, you can see how clear it will be. So the sand on the bottom, the silt, and the clay may still be in suspension. If we measure our clay layer, we can see that we have 0.5 centimeters. So the total of 3.8 is the total height of our soil layer. So you measured the thickness of each layer with the ruler, and you've calculated the relative amount of each component. The formula, percent sand, silt, or clay, equals the thickness of each layer divided by the total thickness multiplied by 100. Then you're going to determine the soil texture using the soil textural triangle, or the online calculator, which has been provided to you in the booklet. Our next experiment is aggregation index. Water will flow through well-aggregated soil more easily than poorly aggregated soil. We're going to place 50 mils of dry soil into a paper cup which has had holes placed in the bottom. And I just used a pen to make these holes. We're placing that cup into a beaker to collect the water. So we have our 50 mils of dry soil, and we have our paper cup with the holes. We have to be ready with a timer, so make sure that students are ready with their timer. This can take less than a minute to happen. First, we'll put our soil in. Then we're going to pour our 25 mils of water, so get ready to start your timer. It goes onto the surface of the soil all at once. And we're going to record the time it takes for all the water to disappear. Stop. So you can see the water's collected in the bottom, none on the surface of the soil. Water infiltration time equals the seconds that it took for the water to go through. In this case, 15.83 seconds. Thank you for joining me today. These experiments will give our students a better understanding of soils, a precious and limited resource. Here at the Dalhousie Faculty of Agriculture, we teach several courses on soil science. Perhaps you'll join me sometime in the future.